Okay, so last week we looked at short division. The children might refer to this as bus stop method as well. So what I'm going to do is I'm just going to do a few examples so that the children can look back this as it was something that we were finding really tricky in class. So we've got 98 divided by 7. So when we're looking at the short division method, we kind of do this, and this is why it's known as our bus stop. So we've got our 7 outside the bus stop, and then we've got our 89. So the first thing that we want to do is we want to know how many 7s go into 9. Okay, so this is your tenths. So really it's 90. So we've got 1, and then we ask the children to then count on. We've got 7, 8, 9. So we have a remainder of 2 left over, which represents 20. So this is why we carry this across to then form the number 28. And sometimes what really helps children, if you use like a bit of paper or a post-it, just to almost like block that off so that it's really, really clear that they can see the 28. And then finally, how many 7s go into 28? And we get 4. There's nothing left over, so it just stands as it is. We do encourage the children, if they struggle with their multiplication, to use a multiplication for this example. Another example we can have is 432 divided by 5. Obviously this is a larger number, but we're going to have a remainder here because we know this 5 here, that this does not end in a 0 or a 5, so there is going to be a remainder. So again, I'm going to draw out my bus stop, put my 5 outside the bus stop, and our 432. And you can see I'm trying to space these out. One thing that children sometimes do is they try to cram it all in so it looks like this, and when it comes to actually carrying those tens across, it looks really crushed. So that's when the children can make errors really easily. So coming back to this one, how many 5s go into 4? So we can't do that actually. So we have 4 left over. So we're going to put our 0 in there, and again we're going to carry this, so we've got the 43. So just writing in that so that the children can actually see that represented 0. 43, how many 5s go into 43? So 5 times something is, and then we want the closest number to 43, so that would give us 40. We want the children to recognise that it can't be 45, so it wouldn't be 5 times 9 is 45 because this would be too much, so we can't manage that. So 5 times 8 is 40, and what is left over? It's our 3, so that we've got our 30, so 32. How many 5s go into 32? Again, realising that we've got 6, and then we've got our remainder, so our remainder of 2, like that. If we wanted to write this remainder as a fraction, then we would just score it out of 5 because we need 3 more parts to make the whole number.